We're reviewing for your calculus test on volumes of solids created by rotations and by cross sections being different geometric shapes. Okay, first one here, they're giving you a region and it's telling you all the bounds already. They're giving you two things in terms of x, two things in terms of y. First thing you want to know is when the region is rotated around the x-axis. Rotation again means we're dealing with circles, so we're thinking with pi r squared. So the volume is going to be pi times some integral because we're adding a bunch of these circles up together. Okay? What we're going to use for it is this function, 4x squared, and we're using things in terms of x because we are going around the x-axis. Okay, so 4x squared, the formula is pi r squared. The function is the radius, so we need to square that radius each time. Okay, and our limits are when x equals 0 to x equals 4. All right, so we're going to simplify that. Pi times still 0 to 4. This will be of 16x to the 4th power. And we need to now take that antiderivative, which will be, keep the pi in front, it'll be 16x to the 5th power over 5, evaluated from 0 to 4. When I plug 4 in for this, I'll get 4 to the 5th, which is a big number, times 16, which is an even bigger number. It's 16,384 divided by 5 here. When I plug in 0, I get just 0. So I subtract those, my answer ends up being 16,384 pi divided by 5 as my answer there for the volume. For part B, find it when it's rotated around the y-axis this time. So I'm going to take my volume. Now, it's still going to be pi times something squared as an integral because we're still rotating here. However, because it's around the y-axis, we need something in terms of y. So what I'm going to do is I'm going to take my original function, 4x squared, y equals 4x squared, and I need to now solve for x to get it by itself. So divide by 4, and then take the square root. The square root of y over 4 will equal x. That is now the function that I'm going to plug in to my integral equation here. The square root of y over 4. That's my radius squared. Now, as for my limits, up here it was when x equaled 0 and x equaled 4. We're dealing in terms of y now, so I need to know what my y values are at those points. So, when x equals 0, plug in to find y, well, it's still just 0. However, when I plug in x equaling 4, what's that mean y is going to equal? So when I plug in 4 times 4 squared is 64. So my top limit now is a big number of 64. Alright, well let's simplify this, see if it looks any easier, and it definitely will. My limits are still 0 and 64. The square root and then squaring it means the square root just goes away. So I'm just going to have, if I can clean that up a little bit, y divided by 4. So now let's take that antiderivative. So keep the pi in front again. It'll be y squared over 2, but I already had a 4 down there, so 4 times 2 will be 8. I'm evaluating that at 0 and 64. When I plug in 64 squared gives me 4096 divided by 8. When I plug in 0, I get 0 divided by 8, which is 0. So I subtract those values. 4096 divided by 8 comes out evenly as 512. So 512 pi will be the volume of that, of that equation, of that region. All right, for C here, they want to know the volume if it's rotated now around the line y equals 64. They're asking you to set this one up. Don't even try to evaluate it. So here's what you're going to do first. Your equations that are bounding this region are y equals 0 and y equals 4x squared. I need to shift those down by 64 because it is this line is like up at 64. We need to shift everything down to bring it to the axis. So my new lines are going to be 4x squared minus 64 and y equals negative 64. What we now need to look at is which one of these is, on the outside, the outer radius. And what I mean by that is, well, here's what the x values are that are bounding it. That means that I need to plug something in between them. So like x equals 1 is an easy one here, or x equals 2. Always something between these two limits. Well, if I plug in 1, for example, here, I get 4 minus 64, which is negative 60. This is still negative 64. Which one is on the outside? Well, if here's what we're rotating around, this top guy is a parabola that's about at negative 64. The bottom guy is a line that's at negative 64. The top one's at negative 60. Which one's further away from what we're rotating? The negative 64. So that means this guy is the one that's on the outside. That is my outer radius. So I'm still rotating, so I'm keeping all of this the same, but I'm going to do the outside guy squared minus the inside guy squared. My limits were still 0 and 4. And that's all you need to do. You can stop right there because it says set it up, but do not try to evaluate it. So again, make sure you go the outside minus the inside, each of them squared. And again, you know this is the outside because it is further away when you plug in. It's further away from where you're rotating. All right, the last part. Find the volume if cross-sections are rectangles, with the height being half of the width. So this sounds ugly to begin with, but first off, think rectangle. The area of a rectangle is just the length times the width. Well, the length is, we're saying, being half of the width. The width would just be how far or how wide all these regions are. The width is the same as the radius from the last problems. So what we're going to look at, it's still an integral. We're still from 0 to 4 because those are our limits that we're going. I should be saying these cross sections are perpendicular to the x-axis, so we know that we're going in terms of x. If they don't say so, just assume that it goes with respect to x. All right, now we're going to have a length times a width. Well, we knew the width already was from our function itself, because that's how wide the region is. Now, the length of each rectangle, or the height, I should say, of the rectangle, should be half of that. So what's half of 4x squared? Just 2x squared. That is your area function, or volume function, I should say. So, from 0 to 4 of this equation, which I'm now going to simplify to be 8x to the 4th dx, I will take that antiderivative, so now it'll be 8x to the 5th over 5, evaluated from 0 to 4. And when I plug that in, I should get 8192, I think, over 5. And do we need a pi? We do not need a pi, because we're doing with a square, or a rectangle in this case, and not a circle. So no pi necessary at all. 8192 over 5. All right, the last two problems. This one, we have two different things being bounded. So when we have two equations, first thing we want to think of is where do they intersect. So let's figure that out first. X squared plus 4 equaling x plus 6. That's when we figure out what the bounds are. Solve this by bringing everything to the to the left-hand side. X squared minus x minus 2. So that factors to be x minus 2, x plus 1. So it means I have x equaling 2 and negative 1 as my two bounds. So my volume is going to have bounds of negative 1 and positive 2. I am rotating here. We're revolving, rotating. So that means I'm going to have a pi times something squared. Now, we have two things here, so I'm going to have a top minus a bottom again. How do I know which is top and bottom? I'm going to plug in into these two equations. Now, what am I going to plug in? Something that's in between my limits. In this case, 0 would be the easiest option. If I plug in 0 for this guy, I'm going to get 0 plus 4, which is 4. Plug in 0 here, I get 6, which is further away from the x-axis. Definitely the linear guy. So it's, again, top minus bottom. Okay, and this is probably going to be the one that's going to be the ugliest for you to try to set up. And I actually say on our review to use the calculator to actually solve and find this integral. So what you're going to do is you can plug this guy straight into your calculator. If you want to try to simplify it, go ahead. You'd have x squared plus 12x plus 36 minus this whole big thing, which would be x to the 4th. You'd then have a minus 8x squared, and then you'd have a minus 16. If you want to try to simplify that, go ahead. But what I'm going to say is go straight to this point right here and plug it into your calculator to see what you end up getting. You will get an answer on your calculator of, I believe it comes out as 50.4 pi. If they had a multiple choice and this was the answer you needed to find out, you would go and type in 50.4, turn it into a fraction, it would come up as 252 over 5 times pi. Now just so you can see where that was coming from, you would take the antiderivative here. It'd be x cubed over 3. You'd have 6x here, or 6x squared, I'm sorry. This would be 30x squared. You'd have a minus x to the 5th over 5. You'd have a minus 8x cubed over 3. And you have a minus 16x. And we got to plug in -1 and 2. When you plug in 2 for the top, you should get 584 over 15. When you plug in the bottom, -172 over 15. You subtract those values and you end up getting 756 over 15, which reduces to your 252 over 5. And again, we had the pi up front, so that's why pi is attached to it. So if you do it with a calculator, that's great, and I'm allowing you to do so. If you do it longhand, that's just fine as well. Now, part B gives you a new line, and again, it says set up but do not evaluate. So what we're going to look at here, still volume will equal something with pi times the integral of something squared. My limits are still going to be the same because when I'm shifting around a different line, nothing's changing here. And again, like we did before, y equaling 2, that means I'm up above. I need to bring everything down by 2 units. Okay, and what's going to happen now is this will be x squared plus 2, and this will be x plus 4. We still need to figure out which guy is on top and which guy is on the bottom. So again, when I plug in 0, because 0 is in this region, I'm going to get 2 and 4. This linear guy is still further away from the origin. So x plus 4 squared, the outer guy, minus the inner guy, x squared plus 2 squared. And again, this should be in terms of dx. And again, you can stop right there. If I said just find this answer using a calculator, you could go and plug that right in. And when you use that integrate function, you should get 32.4 comes out in your calculator. What I'm going to type in actually is just this portion right here. That way I'm not having to deal with the pi. I can tack the pi on later. And if I wanted it in terms of a fraction, I just type 32.4 into a calculator and hit the switch to fraction button, and I get 162 over 5 times pi. So either one of those would be a legit answer if I said use the calculator to find the exact value. Well, there you have your ideas with volumes here, and hopefully we should be in good shape to take care of business.